We have several reagents. See, the best reagent for the mild oxidation is PCC. Note down that point. Best reagent for mild oxidation. Best reagent for mild oxidation is PCC, pyridinium chlorochromate. Because here over-oxidation products won't be produced. Over-oxidation means actually when alcohols are subjected to oxidation, final products are carboxylic acids. First step, aldehydes will be produced and further we'll get carboxylic acid. This is the scenario actually. Clear? But how to stop at the aldehyde only? By using PCC, over-oxidation product. This is called over-oxidation product. Over-oxidation products can be neglected, means inhibited by using PCC. That's why PCC is the best reagent for the oxidation. Reason is over-oxidation products cannot be produced. That is the reason. Okay. Am I audible to you? Hello. Right. Now next keep heading reduction. Oxidation was over. Oxidation of alcohols. Next reduction. Next reduction. What is the reason why PCC is preferred for the oxidation of alcohols? What is the reason? Over-oxidation product can be inhibited. Alcohol's final oxidation product is carboxylic acid. But when we use PCC, it produces or stops at aldehyde only. Up to this only reaction will takes place. Here, over-oxidation product will be inhibited. Okay, right. We remember that point. Which of the following is the best reagent for the oxidation of alcohols? PCC. Okay, one model question, possible question. Next, reduction. We completed oxidation. Next method, reduction. Reduction. Very simple, and one reaction, one reagent only. Hi plus red phosphorus. When we use Hi plus red phosphorus. Reduction means, what is reduction? Reduction means removal of oxygen. Removal of oxygen. See, oxygen is removed. Remove oxygen. Remove oxygen and attach hydrogen to R. Remove oxygen atom and attach hydrogen to R. Because reduction means removal of oxygen or addition of hydrogen. You are removing oxygen and hydrogen attaches to R part. Remove oxygen and attach hydrogen to R part. See this example. Hi red phosphorus. Remove oxygen. Okay, cut oxygen and attach hydrogen to R. R means CH3CH2. So what you will get? CH3. Here you are removing oxygen. Remove oxygen or cut oxygen and attach hydrogen to. Remove O and attach H2. This is reduction. Reduction is small topic only. Okay. Have you completed? Right. Next, keep one separate reaction. Haloform test. Haloform test. Haloform test. See, alcohols give haloform test. What is haloform? Chloroform, bromoform, iodoform. Right. I explained in the alkyl halides chapter also. What is the condition for haloform? Which compounds give haloform? Anybody? I think you are reading alkyl halides, right? You can answer. Which compounds give haloform? How to prepare chloroform? I explained in the first lesson. Tell me. From methane. CO2. No. Haloform test. Ketones with at least one alpha methyl when treated with NaOH plus Cl to produce chloroform. Polyhalogen compounds. Under polyhalogen compounds. Clear? Yes sir, now tell me, have I explained or not haloform test? In the first chapter I explained haloform test. Okay. Once check. Here alcohols with the beta methyl group. Alcohols with beta methyl group when treated with NaOH plus X2, where X is equal to chlorine, bromine and iodine, give haloform. Haloform means chloroform, bromoform, iodoform, and general formula is CHX3. If X is equal to Cl, CHCl3, Br, CHBr3, iodine, CHI3. Okay. This reaction was completed in the first chapter already. Again I am teaching. Okay. See, first of all you should understand what is beta methyl alcohol. Beta methyl, beta position. Methyl group. See, this is alpha position. OH attached to carbon is called alpha carbon. The next carbon is called as beta. In beta position, methyl group is present. Beta methyl alcohol. Right? Beta methyl alcohol when treated with the NaOH plus Cl2. Let us take chlorine in the place of X. Okay. See, very important point. This reagent can be represented like this also. NaOCl. Don't get confusion. When we mix these two, we'll get NaOCl. Okay. I already given this format also in the first chapter. Right. Then what we will get? CHCl3. Chloroform. You are taking chlorine, so you will get a chloroform and HCOH, formic acid. I'll explain the mechanism also. Okay. Clear? First of all, let us write this. Copy this. I'll explain how we'll get this, and I'll give the shortcut mechanism also. Make it fast. Complete it. Right. See the mechanism. CH3C. I am writing O like this, O bond H, and one hydrogen I am writing separately, and here I am writing H. Turn off. CH3 C bond O OH. Okay, and here two hydrogens are there. I am writing separately. I given about mild oxidizing agents list. Once you can check in your notebook. Cl2 is a mild oxidizing agent or not? Chlorine is a mild oxidizing agent or not? PCC, PDC, copper 300, silver 300, and the last I given chlorine, bromine, iodine. These are mild oxidizing agents. Clear? Right. So In the reagent, in the total reagent, you have Cl2. So what is the role of Cl2? It is oxidizing agent. It oxidizes alcohol to carbonyl compound. Oxidation means removal of hydrogens. These two hydrogens will be eliminated. So minus H2. Then you will get double bond at this position. CH3 C double bond O. Here you will get double bond because you are removing two atoms here. At the site of removal of two atoms, you have to put one bond. When you remove two atoms, you have to put one bond, right? And this hydrogen is same as it is. I am writing this hydrogen like this. Okay. So acetaldehyde is produced first. Basically, acetaldehyde is produced. Okay. Acetaldehyde. Okay, this is step 1 mechanism. Step 1. Okay, right. Next, take this acetaldehyde and write in the reverse order. Nothing will happen. CH3 C double bond OH. I am writing H C double bond O CH3. Nothing will happen. Step 2. H C double bond O CH3. Once remember, recall Haloform test in the alkyl halides. I given the shortcut mechanism also for you. Okay. Again I will explain that. See. And this is for the treatment with the NaOH plus Cl2. Now see, look at this. Very simple. First of all, write R. In place of R, H is present. Actually, you know why I am saying R. This is actual reaction. Ketones with at least one alpha methyl undergo haloform test. Here in the chloroform I give. First you have to write R. But in the place of R, what is present here? H is present. So H. And put COOH immediately. Whatever it may be the R. It may be H or it may be CH3. First write that R as it is and attach COOH, carboxylic acid. Clear? Next, place this methyl, alpha methyl is there. This is alpha position. Alpha methyl is there. Convert this to haloform. CHCl3. This part, this CH3 alpha methyl will convert it to haloform, chloroform. And how to write this part? Write R as it is. This is R. Write R as it is. Here R is H. Write H as it is and attach COOH. This is shortcut mechanism. Okay. For example, let us take this only. NaOH plus Cl2. Actually, this is not comes under this heading, but I'll explain once again. Alkyl halides preparations. Write R as it is. R. What we have to do immediately? COOH. Place this alpha place methyl is there, that will convert it to haloform. Chloroform CHCl3. If you take Br2, CHBr3. So this part alpha methyl always converted to CHCl3 or CHBr3. Okay, by heart. Alpha methyl, no doubt alpha methyl always converted to CHCl3. And how to write this? What is present in the place of R? R may be H like this. R may be CH3. R may be CH2, CH3. Write that R as it is. And immediately attach COOH. Clear? Right. Now coming to our original reaction. Haloform reactions given by the alcohols with beta methyl group. Why? What is the mechanism? First alcohol converted to carbonyl. Clear? And from that you will get a haloform. Very, very important. Not all alcohols will give the test, only beta methyl alcohols only will give the haloform test. Okay, right. And one important point, I love you. In place of NaOH, Cl2. You can use bleaching powder also, CaOCl2 and warm water. Warm water, so mechanism is same, everything is same. You can use this also, CaOCl2, warm water. In the place of NaOHCl2, you can use this also. Okay, bleaching powder and warm water, hot water. Okay, sometimes we may get a question with the bleaching powder also. What is its name? Bleaching powder, CaOCl2. This is bleaching powder. Everything is same. Writing the product, everything is same. Clear? So in place of NaOHCl2, if you observe CaOCl2, follow the same procedure. So clear? Are you getting, all of you? Are you following? Are you following or not? Yes. Beta methyl. That only, I am saying from the beginning onwards. Madhima? That only I am saying, na? Alcohols with beta methyl group when treated with NaOH plus H to give haloform. Alcohol with a Grignard reagent. Reaction of alcohol, next property. Reaction of, tell me. Okay. Reaction of alcohol with RMGX, with Grignard reagent. Reaction of alcohol with Grignard reagent. Very simple and very easy. Clear? All of you. What is Grignard reagent formula? General formula RMGX. RMGX. Alkyl, magnesium and halide. Okay, this is already completed in the first chapter. Okay. Alkyl, magnesium, halide. When Grignard reagent reacts with alcohol or alcohol reacts with Grignard reagent, alkane is produced. Alkane is produced. Once look at this, all of you, stop writing, look at this. How Grignard reagent dissociates, tell me. How Grignard reagent dissociates? Grignard reagent dissociates. Very good. R minus and this is the negative and this is positive, right? MgX is the positive. MgX is the positive. In alcohol, this RO is minus and H is positive. H is positive. We know alcohols are acids. Okay, they give H plus ions. So hydrogen is having positive. Alcohols act as acids or not in inductivulent, right? So hydrogen is having positive H plus and this is conjugate base, alkoxide ion. Now attach oppositely charged species, right? R negative attaches to H to give alkene, and this positive and this RO negative can be written like this, ROMGX. This is main product. Alkane is the major product when Grignard reagent treated with alcohol or when alcohol treated with a Grignard reagent. Very simple. Take H from the alcohol and attach to R. Simple. Take H from the alcohol and attach to R. Remove hydrogen from the alcohol and attach to R. Because hydrogen is positive and R is negative. In the Grignard reagent, R is negative. See this example. I am taking methyl magnesium bromide. Any Grignard reagent we can take. Methyl magnesium chloride, bromide, anything you can take. And I am taking methanol, methyl alcohol. What is the trick? Take hydrogen from the alcohol and attach to R. What is R here? CH3 is the R. CH3 negative. CH3 negative. Here hydrogen is positive. Hydrogen is positive. This hydrogen attaches to CH3 to give alkane, that is methane, a gaseous product. In this case, methane gas is obtained, and the byproduct is, you don't worry about byproduct. You can skip also, but write for formality. CH3O MgBr. Okay, this is also important property. Clear, all of you? Another important example is the phenyl magnesium bromide. Who will give the answer for it? Phenyl magnesium bromide. Phenyl magnesium bromide. Phenyl magnesium bromide. When treated with methanol. Tell me, what is the product? What is the main product? Tell me, anybody. Benzene is formed. Yes, correct. See, splitting of Grignard reagent. R negative, benzene ring with negative, and this is positive. In alcohol, hydrogen is positive and this part is negative. So positively charged hydrogen attaches to the ring, negative and positive, so benzene. You no need to represent hydrogen, you can remove hydrogen, you can write a simple benzene ring. If you represent hydrogen or do not represent, nothing will happen. So this is another property of alcohol. So when alcohol is treated with Grignard reagent, alkanes are the products. When we take aryl magnesium halides, then aromatic compound benzene is the product. Right, now we are starting second part. First part is our reaction due to CO bond breaking is our second chemical property. Another chemical property of alcohol, reaction due to OH bond breakage. Another type of chemical properties. Up to now we have seen the reaction due to CO bond breakage only. Now reaction due to OH bond breakage. But these are very less compared to CO bond breakage. These are very less and easy also. Reaction due to OH bond breakage or cleavage. Once again, look at this, all of you. Alcohol is having two types of bond: CO bond breakage, OH bond breakage. CO bond breakage is over already. Next, OH bond breakage. Okay, let us start. First reaction, esterification reaction, Fischer esterification reaction. We are starting reactions due to Fischer esterification reaction. The same reaction will come in the third chapter, carboxylic acids. Same reaction will come because esterification is the chemical property of carboxylic acid as well as alcohol. Only one reaction is the chemical property of two functional groups. So same reaction will come in the carboxylic acids also. Okay, see, what is esterification reaction? Carboxylic acids, or we are discussing alcohols now, so I can start with alcohols. You can give the definition in two different ways. Alcohols when treated with carboxylic acids, or carboxylic acids when treated with alcohols. Based on the lesson, you can change the definition. A reacts with B, B reacts with A. Both are same only, no? But we are discussing alcohol, so start with alcohol. Alcohols react with the carboxylic acids. Carboxylic acids in the presence of acids. Acid is a catalyst. Acid catalyzed in the presence of acids to give esters. Esters are having sweet smell. Sweet smell or fruit smell. Formation of ester is identified by observing the fruit smell or sweet smell, characteristic smell. Right? See one general reaction, after that mechanism, shortcut mechanism, and questions, model questions. Right? Carboxylic acid, RC double bond OH. Carboxylic acid. Alcohol, I am taking R dash. This R and R dash may be same or different, okay? R and R dash same or different. Okay. In the presence of acid, H plus, acid catalyzed reaction. Acid catalyzed reaction. To give ester R, C, double bond, O. I'll give you one question to you. Actually, you don't know this, but I'll ask you because you will remember if I ask you. I'm labeling this oxygen as O18. Oxygen isotope O16, O18. Isotopes, you know isotopes. Hydrogen 1H1, 1H2, 1H3. Similarly, oxygen O16, O18. I am labeling this oxygen as O18. Now my question is, the labeled oxygen will come from carboxylic acid or alcohol? That is the question. The labeled oxygen will come from carboxylic acid or alcohol? Very, very important question. I will explain each and every thing, means how we will write this product. I will give everything. But see, this is a very, very important question. The labeled oxygen, the ester will come from dash. See, here you have two oxygens. Here you have one oxygen. This oxygen will come from this acid or alcohol? That is the question. Now you can answer. See this. Now you tell me, the labeled oxygen is coming from? Labeled oxygen is coming from alcohol. I'll tell you how. With mechanism we can know about this. How you will get the product. First of all, I'll explain shortcut mechanism. Okay. See the shortcut mechanism for it. Follow shortcut mechanisms only always. When original mechanism is important and needed, then I'll give the original mechanisms. This is not a regular or formal mechanism, okay? R C double bond O, OH, alcohol ulta, right? Alcohol in the reverse order. HO18 R, right? Alcohol in the reverse order. See, AB and BA, is there any difference? Nothing. AB, BA both are same. 2 into 3, 3 into 2, both are same only. ROH, OHR, both are same only. Now, remove water. Remove water. And join the remaining, merge the remaining parts. Merge or join the remaining parts. What are remaining parts here? After elimination of OH and H, see RC double bond O is remaining here, okay, and here O18R. Join these two, merge these two by using the bond. Put the bond, clear? After elimination of water, the residual parts are there. Now join them. Means put the bond in between them. You will get RC double bond O, O18R. Put bond between them. Right bond here. Ester. Okay, under arrow right, my next book. This is a very simple mechanism. Here, follow this, then you will get the correct answer, right? But this is not original mechanism. Original mechanism, with original mechanism, nothing use is there for esterification. Clear? But for some reactions, if we know original mechanism, then only we can do the questions. Clear? In that case, we will discuss complete original mechanism. Otherwise, we will go with shortcut mechanisms. Clear? Let us take one example. This is general reaction. Clear? And one important point, the labeled oxygen, isotopic labeled oxygen is coming from alcohol. Remember that point. Clear? Right. Copy this. Have you completed? All of you. Right. Let us take one example. Acetic acid CH3COOH and methanol, methyl alcohol, sorry. Methyl alcohol. You can label the oxygen or not, your wish, okay? There is no condition to label always. You can take simple CH3OH also. But for first example, let us label. In the presence of acid. Acid catalyzed. If acid is not present, then reaction do not take place. Very slow. Acid act as a catalyst. Acid catalyzed reaction. This is. Then the product is CH3, double bond O, CH3. What is its name? What is its name? Names are very important. Give the name for this compound. Methyl methanoate is the wrong answer. Methyl, what you said? Methyl methanoate. M you said, right? Ethanoate. Sorry. I heard that methanoate. Ethanoate is correct one. Yes, correct solution. This is methyl 1 2 ethanoate. Methyl ethanoate. Ester. See, shortcut mechanism, all of you. First write carboxylic acid in the expanded form. CH3C double bond OH. See the condition, from carboxylic acid OH will be removed. Actually, we have to remove the water. In the shortcut mechanism, what we did, look at this. We removed water. Be careful. Water contains OH and H, right? OH should be removed from carboxylic acid. H should be removed from alcohol. Don't do in the reverse order. Clear? From alcohol, we remove H. From carboxylic acid, we remove OH. Better to write here. From alcohol, we remove H. From carboxylic acid, we remove OH. In the shortcut mechanism, OH should be removed from carboxylic acid, H should be removed from alcohol. Okay? Carboxylic acid and alcohol. H, O, labeling. Shortcut mechanism, OH from carboxylic acid, H from alcohol. Completed? Right. We are removing OH from carboxylic acid and H from alcohol. Minus H2O. So join remaining part. What are the remaining parts? CH3 C double bond O, CH3 C double bond O, here CH3O, CH3O, join them by single bond. Clear? For any alcohol or for any acid, follow this shortcut mechanism. Follow this shortcut mechanism. Now let us see the original mechanism. Clear? Original mechanism is optional only. Original mechanism is optional only. If you are interested, then learn, otherwise simply skip. But I will explain. Okay? Completed? Main mechanism. Again, I am taking general equation. General equation. Labeling O18 and isotopic labeling. Alcohol dissociates into H plus and alkoxide ion. Okay. This is considered as a nucleophile. Negatively charged species can be considered as nucleophiles. Negatively charged species can be considered as nucleophiles. Okay. In the step 1, alcohol dissociation takes place, and in the step 2, this nucleophile attacks carbonyl carbon of carboxylic acid. Okay. Main mechanism is optional only. Again, I am saying, if you are interested, learn, otherwise simply skip. Nothing will happen. Clear? Can I write this in the reverse order? RO, OR, both are same only, no? Any mistake is there in this? OR, RO, both are same only. See, in carbonyl carbon, this is carbonyl group. C double bond is carbonyl group. Carbon is having positive, oxygen is having negative charge. Okay, remember that. Now, this negatively charged oxygen attacks positively charged carbon. At that time, this bond will shift towards oxygen to balance the number of bonds around carbon. Here one new bond is forming, no? But around carbon only 4 bonds present. That's why one bond will shift towards oxygen and deposited as a negative charge. Okay. RC, O negative. O negative here O R, OR. Okay, and this OH is common. OH is common. Okay. In the next step, this negative charge shifts in between these two. At that time, OH minus will leave. OH negative. This negative charge shift in between these two as a bond. Okay. Then what we will get? R, C double bond O, R. This is nothing but ester. R, C double bond O, OR. I given R dash now, here take R dash. R or R dash, both are same or different. The ester is formed. This is main mechanism, but you no need to worry about main mechanism. Simply skip it. Nothing will happen. No question will come from the main mechanism. If you learn shortcut mechanism, that is enough. Okay. Copy this. Have you completed? Shall we go to next? Now coming to the question. How questions will come on the esterification reaction? We completed esterification. What is esterification reaction? The mechanism, how to write the product. We completed all. Okay. So question will come directly on the main reaction. And another type of question is, which of the following alcohols? See, we are discussing alcohols chapter. Esterification, a chemical property of alcohol. If I give you 3 alcohols to you, how to select the alcohol which readily participates in esterification reaction? If I give you 1 degree alcohol, 2 degree alcohol and 3 degree alcohol, which alcohol readily undergoes esterification reaction? Clear? Once look at this. You answer my question. This OR is coming from alcohol or acid? Tell me. Alcohol or acid? Alcohol, right? Alcohol. Right. Observe carefully. I said this is a nucleophile. Nucleophilicity, nucleophile, these are related to kinetic terms. Kinetic, related to movement, speed. Okay. That's why I mentioned it as a nucleophile, Rho negative. You can consider that as a base also. Okay. Sometimes base parallels nucleophile. Now consider this as a nucleophile. This nucleophile is moving towards carboxylic acid. See, moving. If it moves fastly, reaction takes place fastly. If it moves slowly, reaction takes place slowly. Nucleophilicity is a kinetic term related to speed or movement. See, if I take smaller alcohol, look at this all of you, simple alcohol. If I take bulky alcohol, motu and chotu, thin person, fat person cannot move fastly. Clear? If I take this alcohol, means this part is bulky, right? Bulky, very big, huge. So its movement is very slow. Bulky size, big size, movement is lesser. So less kinetic effect, less movement. Clear? So reaction also very slow. If I take smaller alcohol with less crowding, here more crowding is there. Methyl, more crowding, bulky. Okay, less crowding. If you take simple alcohol, thin person can move quickly, run fastly. Clear? So this is a smaller group. So if I take this alcohol, means this part will move fastly. Clear? Means like this, O negative CH3, O negative CH3. This is bulky nucleophile, simple nucleophile. Clear? Its moment is more. So the alcohol with less crowding undergo readily, fastly in the esterification reaction, participate in esterification reaction. Smaller alcohol with less crowding undergo esterification reaction fastly. Okay, based on this point I am explaining. Clear? If you do not understand this concept, I'll give you one relation. Just remember that relation. That is enough. Clear? Now keep one statement, right? All of you under note. Esterification depends on the or related to depends on crowding of alcohol in the following way. See, wait just a second. Esterification is inversely proportional to crowding of alcohol. If crowding is more, esterification rate is less. The rate of esterification or simply esterification. Rate of esterification is inversely proportional to crowding of alcohol. Okay. If alcohol is less crowding, rate of esterification is more. If alcohol is more crowding, rate of esterification is less. And I explained the reason also. Once we get this movement, kinetic term. So instead of that, you can remember this. Relation. Smaller alcohol readily participate in the esterification reaction. I'll give you example. See this one. Methanol readily participate in the esterification reaction than isopropyl alcohol, than tertiary butyl alcohol. Tertiary butyl alcohol is a more crowded alcohol, bulky alcohol. So methanol readily undergoes esterification. Order of esterification. Esterification rate is more. It is more towards esterification. Rate is more towards esterification. Okay. This is important question. In the carboxylic acid, we will discuss about order of esterification of carboxylic acids. Okay, because this is alcohol chapter, so we are discussing about alcohol's esterification. In the carboxylic acid, we will discuss about carboxylic acid. That is also same condition. Instead of alcohol, you will write a carboxylic acid. For carboxylic acid also less crowding, same concept. Instead of ROH, we write RCOOH. Okay, in the coming chapter, next chapter. In alcohol or carboxylic acid, crowding should be less, then esterification will be more. Rate of esterification is more. Completed? Have you finished? Right, esterification is completed. Next, reaction with the sodium metal, sodium potassium. Next property, reaction with the sodium or potassium. Reaction with the sodium or potassium. Alcohol when treated with the sodium or potassium will give hydrogen gas. Hydrogen gas will be liberated. Okay. Shortcut mechanism. The sodium metal replaces the hydrogen. Hydrogen will come out as a gas. RONA plus H2. But balancing. To balancing, we are writing half H2. Half H2. See this. Remove hydrogen. Remove hydrogen and replace sodium. Okay. One hydrogen is coming out, but one hydrogen do not exist, right? So I am writing half H2. This 2 and this 2 will get cancelled, so H will remain. Clear? See this example. Methanol, methyl alcohol when treated with sodium metal. Sodium methoxide is formed and half H2. Once you tell me what is the molecular weight of methanol. What is the molecular weight of methanol here? Tell me fastly, all of you. Add all atomic weights. Add all atomic weights. Carbon atomic weight is 12. 32. 32, very good. 32 grams. 32 grams of methanol, because this is 1 mole, right? This is a well balanced equation. This is 1 mole. 1 mole weight is 32 grams. 32 grams of methanol when treated with 23 grams of sodium. When treated with 23 grams of sodium is producing dash volume of hydrogen. Tell me, producing dash volume of hydrogen. How much volume? Half mole of H2. Half mole, half 11.2. 11.2 liters of H2 is producing. Hydrogen gas is liberating. Okay. For 32 grams 11.2, you will get sometimes like stoichiometry relations. 16 grams, how much, like that? Half of this value, 16 grams means. Clear? Then how questions will come on this? So this is a very simple reaction. You are removing hydrogen and you are placing sodium. Okay, everything is fine, but how questions will come? And one probable question is like this physical chemistry type question, like what is the volume of hydrogen, like that. And another model question, how another model question will come. See, take 1 degree, 2 degree, 3 degree alcohols. 1 degree, 2 degree, 3 degree alcohol. And add sodium metal to 1 degree, 2 degree, 3 degree. Take 3 beakers, add sodium metal, sodium metal, sodium metal. From which beaker H2 gas will comes out fast, liberated. Means which alcohol reacts with sodium metal easily, fastly. The more acidic alcohol reacts with the sodium metal readily or fastly. How to know about acidic nature of alcohol? You already completed general organic chemistry. I explained acidic nature in inductive effect. Clear? In inductive effect, you learned about acidic nature of alcohols. Minus I groups increase acidic nature of alcohol. Plus I groups decrease acidic nature of alcohol. So very, very important point. More acidic alcohol readily reacts with sodium metal or potassium metal and liberate hydrogen fastly. Note down that point. You know how to predict the acidic nature of alcohols. Reactivity of alcohol towards sodium is directly proportional to acidic nature of alcohol. Acidic nature of alcohol. If alcohol is more reactive, then it readily reacts with the sodium metal. If more is the acidic nature of alcohol, more will be the reactivity towards the sodium metal. Which of the following alcohol liberates hydrogen gas readily? Select more acidic alcohol. How to select more acidic alcohol? By applying inductive effect. That's why I said to learn general organic chemistry. In second year chapters, we use GOs, nomenclature, isomerism of first year. Okay? I'll give you one question to you. Try to answer. Just copy this. Completed? Finished? Right. Which of the following alcohol readily reacts with sodium metal? Readily reacts with the sodium metal. See, first option, ethanol, isopropyl alcohol, tertiary butyl alcohol. Which is more acidic here? Tell me. Who read GOC recently, or who is having command on GOC? Tell me. Which is more acidic alcohol here? First one is more acidic or last one is more acidic? First one? Sorry, tertiary butyl alcohol is more acidic. What about others? Surabhi, which is more acidic? One degree alcohol. 1 degree alcohol. Ethanol is more acidic. Ethanol is more acidic. Clear? This is less acidic. Moderate. The more acidic alcohol readily reacts with the sodium metal. This is more acidic, so readily reacts with the sodium metal. Okay. We'll continue tomorrow. Tomorrow, based on other students' response, I'll take the class. Okay. And in the meanwhile, you go through the alkyl halides perfectly. Okay. And Bhakti, can you send the material questions? I'll prepare worksheet, means slides I'll prepare. Okay. Bhakti, now leda. Who will send the notes? Adiba, can you send your notes? Material questions only. Alkyl halides. Okay, send the alkyl halides. I'll prepare slides. Okay, that is very helpful to you. Okay. Bhakti, you are sending alkyl halides. First chapter. No. Material, Chaitanya exercise questions. Send the questions, exercise 1, 2. We'll do the questions tomorrow. Okay.